Bright Duty. Every student matters.
Hello students, my name is Sanjay Jain. In the last lecture, we discussed about figures on the same base and between same parallel, right. So, in this lecture, let me start with, if I have got two parallelograms on the same base between the same parallels. The parallelograms on the same base and between the same parallels are equal in area. How would you imagine the situation? Let us say this is one of these parallelograms and these two lines are parallel. Okay, so L is parallel to M and there is this parallelogram ABCD on base AB and between parallel lines L and M, and let us say there is another parallelogram ABMN which is also on base AB and between the parallel lines L and M. Now, these two parallelograms are equal in area. So, parallelogram ABCD and parallelogram ABMN are equal in area. This is what we have to prove, right. So, tell me, if let us say this region I consider, this is the region which is common in both these parallelograms that we are talking about, right. Apart from this common region, this is a common region in these two parallelograms. Apart from this region, I have got these two regions, this one and this one. Okay. That means, let us say this region, area of this region is A1, okay, and area of this region is A2 and area of this region is A3. So, if I need to talk about area of parallelogram ABCD, can I say it is equal to A1 plus A2, as we discussed in the introduction part, that this region consists of two regions ABMD and BMC. So, we can add the areas of these two regions to obtain the area of parallelogram ABCD. So, yes, it is equal to A1 plus A2, and area of parallelogram ABMN, can I say it is sum of areas A1 and A3. So, if you notice in these two parallelograms, this area A1 is common, right. If I can prove A2 to be equal to A3, then I can say that two parallelograms on the same base and between the same parallels have equal areas, right. So, this is the common base. Let us try and prove the A1, the area A3 and A2 as equal. Okay. So, first of all, tell me about these two angles. Let us say this angle here, let me change the color. Let us say this angle here is alpha. So, can I say that this angle is also alpha? Because these two lines are parallel, AD and BC are parallel lines. So, these two angles are corresponding angles. Angle alpha is corresponding angle to this angle, which is also alpha. Okay, hence these are equal. Now, the same thing can I say about these two angles, this angle and this angle. If this angle is beta, will this angle be also beta? Yes, because AN and BM are parallel lines, because ABMN is a parallelogram. So, these are parallel lines, and this angle beta is equal to this angle because these are also corresponding angles, right. So, two angles of these two triangles are equal, hence the third angle, that is this one, will be equal to the third angle of this triangle, that is this one. Okay. So, if I name it, let us say theta, this angle will also be theta. Now, if you notice in triangle ADN and triangle BCM, all angles are equal. And what about sides? Can I say side AD is equal to side BC? Opposite sides of parallelogram ABCD. Now that I have shown two angles as equal and one of the sides as equal, right, then I can say that by angle side angle congruence rule, triangle ADN is congruent to triangle BCM, and if these are congruent, their areas are equal. So, area of triangle ADN is equal to area of triangle BCM. That means A3 is equal to A2. A3 is equal to A2. Now, equals can be added to equals. So, let me add A1 on both sides. So, A1 plus A3 is equal to A1 plus A2. A1 plus A3 is nothing but area of parallelogram ABMN. ABMN, and A1 plus A2 is nothing but area of parallelogram ABCD. Right. So, you can make any two parallelograms on this base, let us say. Okay. This is, let us say, the common base, and if you make this parallelogram, you make another parallelogram on the same base and between same parallel lines, you make third parallelogram like this. Okay. All of these parallelograms that I have shown you will have equal areas. One is this one, right, base is same for all of these. Another parallelogram is this one, right, and third parallelogram is this one. Okay. So, these, all of these parallelograms are on the same base, that is this base, and between same parallel lines, these two parallel lines, hence these parallelograms have equal areas. And how can you prove that? You can take common area, common region, and apart from that common region, you will have two triangular regions of which the areas will be equal, which you can easily prove through angle side angle congruence rule. Okay. I hope this theorem is clear to us.